Now, okay, now I'm recording. Um, so wow, okay, all that information about just so if you are watching this video, I can say it again. There's going to be another video for Perforce, just in case you missed the one or two people or you're watching it again. There's going to be a separate video for Perforce. Look out for that one. Okay, back to today. Huh. All right. So today we're going to talk about Unity. We're going to get into Unity itself, how Unity, its sort of architecture, its philosophy with regards to programming and organization and architecture. A lot of it is going to feel a bit like data structures. Some of you are taking data structures now. And so we're going to be talking about data structures. We're going to be talking about objects and classes and components, which is something unique, not entirely unique to Unity, but something about the way that we organize things in Unity and other game engines. So we'll be talking about a lot of those concepts, as well as kind of how they are presented by the Unity editor and the Unity interface, right? So it may seem like all we're doing is pasting some buttons on a screen, but underneath the covers, there's a lot of data structures and management and objects and all that kind of great stuff going on. So the more we kind of comfort, we assimilate ourselves to that, or we acclimate ourselves to that. The sooner we do that, the better, right? Okay, so here we go. And I guess I can keep myself up for that first slide, but let's see how this immediately goes. All right, I'll immediately be in the way of things. So I'm going to go ahead and turn that off. And where did my pop-up screen with everybody go? I wanted that just in case there. So I've got the screen up. I also have the chat up. So this way I'll be hopefully, if I see people starting to write stuff in the chat, I can jump on top of that. All right, so if you want to interrupt me, go ahead and where is that? It's over, I guess, in spring 2022 general. Okay, I'm over there. All right. Here we go. Okay, first off, let's think about this big picture again, okay? The coding big picture. Games and programs are made of rules and data. Typically, when we talk about rules, we may refer to functions. Now, in math, function has more of a strict meaning in terms of you have a function that operates on some variable or variables, or or something it's given, and it will give you some output. Normally, it is like the function, the square root function gives you the square root of whatever you gave it, right? So you wind up with a number that comes back out again. We may have, technically, if I was, a strict computer scientist here saying, oh, what's the difference between a function and a procedure, for example, or a routine or a subroutine. There's lots of names that we can kind of use, and they'll be, we're okay using them a little bit loosely. They are basically the rules, though, right? This procedures, subroutines, rules, functions, and so on. So sometimes in the case of procedures, it might be, okay, you give it something to do, and maybe you give it a variable, maybe it has an input, maybe it doesn't. And instead it's just, okay, do some stuff, carry out this procedure. So that's a lot like a function, but it may or may not take some kind of input, and it may or may not literally give you back some output. Instead, it may affect the state of the system that you're in, right? So we do have these rules and procedures that are going on. And then we have data in our program. And we start to introduce the concept, right? We have the idea of having variables or named variables, which are just containers for data, right? Or ways to reference data. Like I might have a box here called name, which is a variable. And it's kind of neat here in that the name of the variable is name. All right, a little bit redundant, a little bit, Anyway, and in that box, I put a string, which a string is just a bunch of characters all put together that somehow I know that there's a beginning and an end to it, right? So there's 1, 2, 3, 4, 5 characters in here. It may have an invisible character at the end, which is the end of the string, some magic character just to let me know that there's no more after it, believe it or not. And I take this string and I put it in the box. So now whenever I want to know the name, I want to say, okay, what was that variable? Okay, give me the name variable back. And I would look at it and be, oh, there's Maria, okay? So data is usually contained within named variables, all right? And in, kind of abstract computer programming or computer science, a variable really just is something, it's a spot in memory perhaps that has some way of, some way of referencing it and so on. It doesn't have any functionality associated with it. It's just out there on its own. It just lives on its own. Same thing for the functions and procedures. They're just like, they're on their own. Maybe they know how to reference some variables, but in some cases they have to be presented with them. There's really no kind of connection between them. But in our case, we're going to see that it's going to be useful to consider them to be connected and to use programming paradigms that connect them for us and help enforce those things and facilitate those things. All right. So in order for computers to understand these things, of course, they need and we need to agree with and comply with their syntax and semantics, right? Syntax is sort of like, okay, the overall context, how things are used, and semantics are going to tell us, okay, how do I gather meaning from this presented bunch of information, right? Semantics is going to help us get meaning from context, right? So, for example, in having to understand context, here's in the little cartoon here we have the instructor asking, "What does surrender mean?" He's got surrender up there on the blackboard, and the student in the back eagerly says, "I give up." Now, I could make one of two assumptions here. I could say, well, the student knows exactly what the instructor is saying or asking, and the student knows giving up is surrendering. Or the student is giving up on actually providing an answer. So maybe the student has no idea what surrender means and is instead just coincidentally giving up. That just happens to be the meaning of surrender. So, as you can imagine, without the correct semantics and syntax, you have to make assumptions, which is, dangerous, especially when you talk about computer programming. You want to be as clear and precise as possible so that the computer does exactly, and it will do exactly what you program it to do. Maybe not what you intended it to do, but it will do what you programmed it to do, right? So that's the challenge there, is to make sure that your intent and what you implement are the same, right? Now, just as an example, if we looked at some syntax and semantics of English, if I said the cat sat on the mat, you would know what I meant. You would know that the cat is on top of the mat, and the cat is the one that took the action to sit on the mat, right? You wouldn't think that somehow a mat dropped on a cat. You wouldn't think the mat is sitting on the cat, because you understand the content or the semantics, the syntax of the sentence, right? The cat, that's a noun article there. So the article, the noun becomes the subject. It precedes the verb, which is the action of the sentence. The cat sat, and then we have a prepositional phrase with the preposition on, and a noun phrase at the end, the mat, right? So we know the mat is the thing being sat upon, and the cat is the thing doing the sitting. So even if I started juggling things around, I might say, on the mat sat the cat. All right, so there, a good example, yeah, means the same thing, but maybe there's some semantics in there that you are inferring. Well, in the case of saying on the mat, we know that is, something needs, that's a prepositional phrase, on the mat, right? So if I said the mat on the cat sat, now we're getting even more vague. The mat on the cat sat. The mat on the cat sat, right? Now, if you know what a cat is, and you know what a mat is, and you know what to sit is, right? Now we have some context that isn't necessarily about syntax, but the semantics of it. You know the meaning of the word cat, the meaning of the word sat, and so on, right? So from that, you're also gleaning some of the meaning, and you get the correct outcome of the sentence, right? Even if we really Yodify things up. This is why we still understand what Yoda says, despite the fact that Yoda often uses Yoda's own syntax and word ordering and so on, right? So there's that, right? And it's helpful to have as precise a way as possible to actually write things down, to embody your intentions so that the computer can deal with them. That's what coding is all about. Okay, we have these structures that will help us to do that, and we have syntax and semantics that'll help us to help the computer to know what we intend for it to do. There's lots of styles of programming. This is really just a short glossary. You may or may not ever refer back to this one, but there are lots of different approaches to programming, and you should be aware of them. And what we're going to do in this class is we're going to play things, not necessarily, I want to say fast and loose, but in this sort of hybrid where we're going to be employing different styles of programming depending on what it is we want to do and how things are implemented and what the engine requires. Right? Unity has lots of ways for us to actually implement features, for everything from using an animation timeline to writing a script to extending objects to creating libraries or creating templates, all these sorts of things that will be reflective of various styles of programming, right? And how you in the end use Unity, you're going to have your own style, you're going to have your own things you like, things you don't like, ways you want to use your code or want to structure things and so on, right? And these aren't styles. I don't mean style like, oh, I like to indent my functions, or I like to indent after curly braces, or I like to have the curly brace on the first, after a character turn after the if statement. Yeah, that's a styling with regards to how it is on the page, but functionally that's not the kind of style of programming I'm talking about. Right, that's style just for readability, really, most of the time. And also, sometimes we use style like that to help us avoid writing buggy software. If we have certain style guides and we have ways of writing things so that we understand, how we structured things. Having, I always find that having the braces or curly brackets around blocks of code is really useful for understanding, okay, here's some functional unit, or here's some module, some scope that tells me these things are all happening together, versus if you have an if statement with just a single line after it, suddenly you're like, okay, is that happening? Or some other languages, indentation. I don't like languages that change scope by indentation. So this is just an example, right? Lots of different styles. So you can do things like, have functional programming where you just sort of say, okay, this happens and it is completely independent of anything else. This happens completely independent of anything else. And you write your programs, you write your functions that way, right? Without making any assumptions about what happened before, what happened after. That's called functional programming or stateless programming, right? So you design things with as few assumptions as possible. Or you might have things that are more imperative programming, where functions can manipulate some sort of state that the program maintains, so that these functions are more saying, okay, what state is the game currently in, and therefore what should I do because the program is in that state? And suddenly in those cases, it's very important to know what's going on, as opposed to the functional where you don't care, right? And these are, you can adopt one or the other. And as you get into for those of your CS majors, you're going to take principles of software design, you're going to take fundamentals of computing, and you're going to be talking about programming patterns, and all these things will come back and haunt you. And you'll get into far more detail on, right? You're going to hear about various programming paradigms, about procedural or functional programming or modular programming, right? And it's to our benefit to kind of learn from all of these things and help us use them to organize our code, like thinking modularly, right? If we want to have an object moving on the screen, for example, then it's useful to have all the code that is involved in that movement and the presentation on the screen all together, as opposed to like, well, if something could have forced your object to move and it's in some other crazy location in some other script somewhere, and you don't know where it is because you chose not to kind of organize by functionality, you can imagine, all of a sudden things behave in weird ways, and it's tough to track down where that happened, where this happened, and so on, right? So modular programming is a good thing. And one of the big things that we will talk about that will be a common thread throughout is the object-oriented paradigm, the object-oriented approach to programming. Most programming languages, and certainly C# are object-oriented programming languages, and they are ones in which data and functionality are encapsulated together. They become co-equal considerations. They work together. They're not just kept separately. So when we design things, we design them with both their functionality and their data in mind. We create objects that that hopefully know and contain as much of a certain amount of functionality or the procedures necessary. Like imagine a person knows everything about, the person contains their own information in your head. So okay, when I need to walk from here to there, you know what your stride length is. You know how intrinsically, perhaps, how to put one foot in front of the other. You don't need some external force telling you what to do. Now, external forces may cause you to make decisions about how you put your foot down or how far, how you adjust and so on. But internally, you have the knowledge and the information that you need in order to take action, right? You can stand on your own. You are an object, right? That's the sort of idea behind an object. And then we have types of programming and user interaction, which really come down to more kind of architectural issues, right? So the structure overall of our code in terms of how the system works, kind of system level programming. Things like, do we respond to events as they happen? So like the user presses a key or the mouse is moved or two things collide on the screen. Do we immediately say, okay, an event occurred somehow and therefore we run code in response to that event, as opposed to some code that just keeps continually executing through some known number of states and it's eventually going to get to servicing everything, the automata-based or polling-based code approach, right? So we have different ways here, and we even have what we'd call real-time interaction or real-time processing, where code isn't tied to necessarily an interaction with the user and instead just executes because time passes, right? So we have all sorts of different types of programming, paradigms of coding, approaches and styles of programming. All right, be aware of them. There's no one that necessarily fits all. If I were to say, one common thread that runs throughout a lot of what we're going to do, of course, is going to be object-oriented programming, but we'll hit on kind of all of these things depending on the circumstance, depending on the need, depending on, what works best. All right. So that said, there's also things that we get, and the way we're going to approach programming in here is working with an engine versus working with a language, right? The idea, you might say, well, I'm writing a game in C#, I'm writing a game in C++, or now we're writing a game in Unity and we may be using C# as our scripting language. That's different, right? We're using the Unity engine versus, say, using the C++ language. And there's those gray areas, of course, where we say, well, we're using C# within scripting inside the engine. But the reason we work with engines generally is that the engine is going to provide or abstract out a lot of these sort of grunt work from the development, the things that someone else thought of and we agree with, hopefully, that are just sort of like common things that every game is going to need to do, and abstract it in such a way so that it becomes generally useful. So I can say, okay, at some point do this, at some point do that, in response to this do this, right? So I have some general purpose abstracted tools for things like when things collide, or I need to play some sound, or I want to blink the screen, right? There's common grunt work, common functionality that we want to be able to use. Now, often this allows you to work at what's called, we say sort of a higher level or object level and point and click level rather than at a code level, right? Because we define certain things about objects and certain characteristics of those objects and certain behaviors of those objects. Me, as developer of the engine, I can say, okay, there's a sprite on the screen that someone wants to animate, so I will create an animate behavior that uses a sequence of bitmaps for perhaps, and I'm going to create an object that knows how to keep all that in there so that you, as the game developer, can just say, just give me an animated sprite, and I can just give you the right data, and boom, everything else, right? So that's sort of an object approach an object-oriented approach where somebody can create these objects that have these functionalities, have these capabilities, and have the agreed upon interfaces so that someone else can then use, right? Okay. So that's a little bit of object-oriented architecture. Now, throw that word object around a lot, and we're gonna be a little bit loose in how we talk about it, because we're going to typically talk about game objects within the context of Unity, right? Unity has game objects, and those objects aren't exactly the same as the objects in object-oriented programming, right? Unity game objects are really just sort of it's a data structure. It is a specific type of data structure that represents something in the game, right? And it will have, perhaps it'll have children that are other objects, or often it will have behaviors and data that are associated with it. And we're going to get into those when we discover what those components and what's inside of those components and so on. Right? But game objects, when we refer to them in Unity, they're not exactly the same as an object from a purely sort of object-oriented programming perspective. So be aware of that. We're going to be a little bit weird in that regard. But let's imagine, let's abstract ourselves. We'll stand back, take a much higher level view of what's going on here. And every so often, I'm just going to make sure that, yeah, it's still recording. Everything still seems to be going okay. All right. So we have these objects in our games, right? We have the player, we have the enemy, we have the building, we have the slingshot, we have the wheel on a car, all sorts of game objects, which are things that have characteristics and quantities and qualities and so on, and they have behaviors that they can do, right? The player can run around, the player can respond to the real player's input and so on. So these objects have within them all sorts of different types of data and all sorts of different types of rules that are associated with them, right? So game object is this bucket, or we often say it's a big bucket of code and data, right? It's a big bucket of code and data. It has all that stuff in there. Now, how is it organized is the question, or how can we organize it in ways that make sense and are extensible and are scalable, and so when it comes to needing a zombie horde army as opposed to just one fluffy bunny on the screen, the game engine still works and provides what we want it to, right? So let's think about that. So here we have these blue data floating around inside of this bag or bucket, and we have these red rules also floating around inside here. And the idea in object-oriented programming is that this object contains them both, right? So it knows about all the data and rules. It knows that how hungry is it and what to do if it's hungry or not. When you reach this level of hunger, you better go out and find more food, or you're not hungry at all, so therefore you put your energy into something else, right? These are things, the game object itself can do things based on its current state and its procedures, its behaviors, its rules. Okay. So, as a thought experiment, what are, and not all of them, but what are some of the rules and data that you would associate with a cart in a game like Mario Kart? All right, so I'll wait for some people to shout out some answers to this, and I'll use that as an excuse to have a bit of seltzer here. Speed, right? That's a good bit of data. It's good to know. What speed is the cart running at? Give me another one. Exactly, direction you're going in, right? That's important to know, right? Speed on its own is not enough. We need to know what direction the car is traveling in. Give me a rule. Give me some kind of action that we would do. Yeah, an interaction with other players. What happens when you collide with another player, right? Does the car get damaged? Does the cart get damaged, right? Does it veer off in another direction? Does it have some sort of collision impulse response that needs to happen? Any other ones? I can't quite understand you. Your connection must be really slow or something. It sounds like you get the real robot voice there. You're gonna put it in the chat. I think that's what you said, right? Okay. So feel free, everybody. You can always go ahead as I ask questions like this. Feel free to put stuff in the chat, and I'll try to respond to that. Speed, acceleration, traction. Yep, all these sorts of things. Those are all data. Now, what kind of other rules would there be? right? Well, that's an interesting one. That's an interesting one. Is that a property of the cart, or is that a property of the track or the environment, right? So that's something that, how would the cart know what its relationship to the track is, right? In an abstract sense, it probably doesn't. It just knows its position in space. Now, maybe there's some sort of interaction, but you're getting into sort of a gray area, right? Now, slow down off road. Okay, so the way that you respond to maybe I'm misunderstanding what you were saying. Slow down off the road. So your traction on a different type of road, that's also getting a little bit, some data in terms of the external forces versus how your tires deal with them and so on, right? So there's lots of things like that. I feel like the cube thing would be a mixture of data where it knows what it will do and rules like how it will be used by the user, right? There definitely are parts of it, right? And to figure out, like, for example, in the case of the cart certainly has to know, and here's the one we were kind of alluding to, these intersection boundaries. It knows how big it is, right? So it knows at some point the space that it occupies. Now, at some point there may likely need to be some resolution between either multiple carts where, okay, we have some kind of collision box or some kind of hit box where two carts try to occupy the same space and they wind up colliding. They wind up intersecting. And in the case of a track, you may have, your environment where the engine itself is saying, okay, are the intersection boundaries of this particular cart still within the context of the world, right? So there will be larger systems at work that are going to try to resolve relationships between our objects, right? And sometimes, each object will have to know and be able to tell the world, like, here's my boundaries, here's my speed, here's the direction I'm going in. Right? So there definitely is a mixture of what it knows and then what the overall system and environment know and then how they interact and so on, right? So sometimes there will be reaching outside the box to look at data that's not necessarily stuff that's inside, and sometimes the world will and other objects will ask, well, what did I just collide with, right? If I collided with something really heavy, I might get damaged more than if I get, feather bumped into me. Right, so there's going to be lots of interaction and lots of interaction of code as that sort of stuff happens. But let's look at kind of the stuff that would be unique to the cart and hopefully provide the environment or the push us in the right direction. Now, okay, here's a real good one came in. Since the carts are customizable, are the wheels and glider also considered parts of the cart? Right? That's a really good question. Now, because wheels, the glider, even the character driving the cart, are they their own object? What relationship do they have between them and the cart? Now, those type of situations often are handled as having some sort of hierarchy, right? Where the cart, someone's confused on datas and rules are organized. We'll get to that, okay? How they're organized. Now, in the purest sense, we create some sort of thing, and in the C# and C++, we're going to create classes which will be defined, and they're going to have the rules and data that we need to know about in them. Right? There's going to be data and rules inside of a class, or in the case of Unity, we're going to have a specific type of class called a component. Right? That's going to contain those things. So we're getting a little bit ahead. It's a couple of slides from now you'll see it. So here we have all of this stuff that we think describes the cart in an abstract sense. It doesn't have to know about the world. It doesn't know about other characters or the track and so on just yet. They're kind of the main things we would think of. The maximum speed, the current velocity, the intersection boundaries that describe, again, the space that the cart would occupy. How to display the cart, right? That's going to be important. Is it bitmap on the screen? How do we turn the cart? How do we change the direction? So when it's time to turn, we may need to call the turn routine, right? Now the red ones, remember, they are rules or procedures that are going to be functions that we call to change things over the course of time, and not just an abstract, okay, here's a bit of data, right? So you might say, okay, put on the brakes and skid, right? There's some thing that tells us, okay, what happens during a skid? What is the action of skidding like? What happens when you hit another cart? What happens when you deploy an item? These are sort of actions as opposed to these quantities of position, size, turning rate, and so on, right? So we have these different things, and sometimes, in some cases, we'll have things that are going to refer to multiple parts. So maybe displaying, that might need to know the position of the cart in the world because it needs to know where to draw it. Now, hitting another cart, that might also need to know about the position because, well, we have to know where it is and what its intersection boundaries are in order to see, did it hit another cart, right? So sometimes these things will be used by one another, but we'll have to have some means of, asking about them, organizing them, structuring them, and so on, right? So how do we organize these things further? Now, the basic building block that we're going to use in Unity, or the important building block we're going to use in Unity, is something called a component, okay? So a component is going to be really the level of kind of a useful feature. You can think of it as a feature of an object, right? So like in here, for example, the transform, something that every object has, there's a few of these the light green ones are built-in Unity components. The first one's called a transform, which has a position, which is an X, a Y, and a Z, so we know its position in the world in 3 dimensions. It also has an X, a Y, and a Z rotation, so we know how it is oriented in the world. And it also has an X and a Y and a Z scale or size, which tell us, is it scaled in the world? Is it big? Is it small? So the model may be modeled at a certain size and, Mario ran over the right mushroom, so it grew, right? So the scale may change and so on. And it might hit a wall, in which case, the Y might get squished down in 1 dimension or something like that. You may play games like that. But here's the transform component, which is a grouping of the spatial and orientation quantities of the object. Good to know, good to have, makes perfect sense that it be that sort of unit. Another component that Unity provides something called a sprite renderer. There's going to be different types of renderers, which are how objects present themselves on the screen. To present a sprite, well, we need to know about an image, which might be a bitmap, and then we have to have some way of how do we display a bitmap on the screen, right? So a component ultimately, we implement components using C# classes, right? So they are, and a C# class is officially how objects are implemented in C# and in C++ and in other languages as well, right? So you have these objects, which is an abstract thing. An object is a very abstract thing. A C# specific is going to be, we're going to use classes to create these objects and describe them. And a component is a real Unity thing, right? It is a data structure that is derived from this general class that we're going to use. Okay, so the component is a specific thing that's going to allow us to implement or put some sort of associate a feature or a functionality or capability with an object in the game. All right, it might be that necessary component to make the game object respond to physics, or it might be the component that allows it to be rendered on the screen, or it might be an audio source component that allows it to be heard, right? It's going to be that object, or that, this is where, like I said, it gets a little bit weird because object is just a wonderful general term. The component is the thing that allows that game object, gives it its behaviors, right? So we use lots of different components to grant behaviors to our game object, right? Now notice on here, okay, in Unity, objects are containers for components. So our cart may have all of these different components, 1, 2, 3, 4, 5 components on them, right? The standard ones, the transform, the renderer, and the physics component. And then we might write custom components, things like, handling, okay, how does it drive, right? How does it change its position? What happens when it turns, and so on. We're going to write behaviors for that and decide what data do we need to implement those behaviors. And we also might have things like maybe it's an inventory that it can hold, right? It has an item manager. It knows the current item. It knows how many items it has, right? The current one in your hand and additional ones. It might have a whole list of items that you might have. And it might know then, okay, you have to deploy an item. So that means some sort of interaction with the item itself. Maybe the item is actually an object. So yeah, there's going to be a little bit of interaction going on there to determine, what sound does this particular object make, and so on, right? So our item manager may need to play the sound of the turtle shell that it throws or the banana peel that it throws, and so on. But the item manager itself is a component that may help us deal with other objects. Whew. Okay, so components are implemented using C# classes. And then we're going to throw another object-oriented word here. These classes, they inherit from monobehaviors. Okay, a monobehavior is a class that Unity provides that contains real basic functionality that it thinks every component should potentially have, and then you add more functionality to that, right? It is the blueprint, right? The monobehavior is basically, the starting point, the base class for any component in Unity. So don't worry too much about all this sinking in just super precisely. It will make more sense as we get into examples, all right? But just know that, yes, there's this structure. We have game objects, and in Unity, game objects, we assign, we add on, we put components onto those game objects in order to give them functionality and make them work in the game that we want, the way we want them to, right? We don't necessarily need to have, here's a foot soldier, here's a artillery soldier, here's a horse. We don't need to have those sorts of things because maybe we do, but they may have shared components across all of them. Like the horse soldier may be able to shoot a bow, which actually the artillery could also do. So there's a component which is the notion of attacking with a bow, right? A bow attack. That might be a component that has arrows and how to shoot an arrow and so on, right? So don't worry, we'll get there. With the more examples and actually trying out things, it'll make more and more sense, hopefully, right? Just think of it this way, right? We'll abstract it a little bit. We have the game objects, which are the things, the nouns in the game, right? All independent objects, both those on screen and off screen, those are game objects. Occasionally, we'll have game objects that function as sort of a hierarchy of their own, like the cart that has wheels, right? A cart has wheels. So the cart is a game object, and those wheels are game objects. And maybe the wheels come flying off the cart, and they're going to have independent behaviors because of that. So that happens, yeah. But let's think a little higher level for now and just say, okay, the game object, the one that we're looking at here is a noun, which is the cart, which we'll assume the wheels are still attached to. So it's a object there. And that object will have functions, rules. The cart turns to the right, the cart turns to the left. But in order to do that, those rules have to be contained within something called components, right? And a component isn't just functions. It's not just rules. It also is data as well. So components have functions and properties, or data and rules in them, right? The properties of that component, the adjectives, they are contained in there as well, right? So we have a location, we might have health, we may have the number of ammo, the number of arrows we have, and so on, right? We have an arrow, we have 10 arrows, that's something, but then we have the action of shooting an arrow. Okay, that's something too, right? So that might be the component. It might be some type of projectile attack that we have, right? So the component is a container that contains groups of related functions and properties, and you add those to game objects. And you can share different types. You can say, okay, the enemy is going to have a weapon. The player could have a weapon. The horseman could have a weapon. You could implement one component that is that weapon and then give it to whoever you need to, and maybe give it to multiple ones, right? So components, they are their own sort of object in the object-oriented way as well, right? This is a little bit, we're drinking from the fire hydrant at this point. Definitely is a lot of stuff. But again, once you start using it, it will make sense, right? So those are the main object pieces and the component pieces. And the events are sort of a special case where there's going to be these conditions that now kind of hook a behavior or a rule to something that will sort of trigger it. It's going to apply the function to a property on a component of a game object as part of the system running, right? The system is somehow going to interact with your object, say, hey, Mr. Component, a frame needs to be drawn on the screen. So I need you to do what's required for you to update the screen, to update you on the screen, right? So the event is going to be this condition within the system that's going to then ask your component to do certain things, to apply functions and properties within that component of that game object, right? So when a button is pressed, when two objects touch, every time a frame is drawn, maybe it's every second, anything like that, that's the event at which point the system is going to ask your game object to run certain components, and the component needs to run certain functions using its data. Right? So it's all about this hierarchy, this kind of dance that goes on between there. So some concrete examples: an event, an object, a function, a property, a component. So think, if the D key is pressed, that's an event. So the system is going to say, all right, anyone, there's a D key event being played, and it's going to ask all of the objects, okay, here the player is going to say, okay, I got something to do with D. So therefore, the player is going to use its transform component, perhaps, and it's going to have a function to move it to the right, which is changing its position. Maybe there's another, okay, the system will say, a new frame needs to be drawn. All right, so now the objects within the game, the enemy ships on the screen, they're going to need to run their functions that react to that event, right? So on that event, they will then move towards the player's position. Maybe they're looking at something of another game object, right? So there can be these interactions between objects, and you can ask an object about itself if you need to do something. Say, oh, hey, where is the player, right? So all enemy ships move towards the player's position, right? You might have a collision event, and this is something the physics system will provide for you. And the physics system will say, oh, hey, look, I figured out these two things based on their components, they're going to collide. Do something, right? So we'll resolve, within these components, they're going to have to look at their data and rules in order to resolve that event, and so on. Okay. Now, an important thing just to know, and this is for future reference. So there's just to be aware of the way the structure is sort of working, especially when you think about object-oriented programming and inheritance and this sort of thing. There's two important types of relationships that we need to kind of know about, think about. And they're the has a relationship versus the is a relationship. Okay? Has a versus is a, or has a, is a. So the typical way we talk in Unity, we often say, okay, this game object has this component on it, right? The player has a character controller, the player has a rigid body 2D, the player has a sprite renderer, the player has and we give it whatever components it needs, okay? So we're not really creating this player object, we're just taking an object and giving it these components that in the end wind up kind of turning it into a player because it's going to give it all these capabilities. Whereas if we were looking at a somewhat more traditional way of doing programming or doing object-oriented programming is we would be thinking more of a is-a relationship, where at each step along the line, each step along the path here, we would create an object that did certain things, and if we needed it to do more things, we would then derive something, a new object from that other object. So that object would be, say, a soldier, or a foot soldier is a soldier. So a foot soldier can do everything a soldier can do. And then a heavy foot soldier is a special version of a foot soldier that can do everything a foot soldier can do, that can do everything that a soldier can do, right? So a foot soldier is a soldier. A heavy foot soldier is a foot soldier is a soldier, right? So it's a little bit different. But Unity has a relationship, and we implement functionality in Unity by giving Unity game objects components. All right. As opposed to other engines, if you're used to things like Godot or Unreal, you may instead be saying, okay, I've got a node, and a node can be a sprite, and a sprite can be a player, and a player can be a, and so on and so on. All right, a little bit different. Okay, so keep that in the back of your head. Be aware of those things. It'll make more sense as we roll up our sleeves, right? And it's tricky because on this slide, this kind of gets the frustration of that you're probably feeling a little bit right now, and saying, okay, well, these are all conceptual things that are very fuzzy and tough to kind of understand in as abstract things, right? And the problem is because, well, what do we do? Do we, we've got these concepts. Do we actually start programming? Do we see how they're working? Do we have to talk more about and it's a real chicken and egg. So what I like to do is kind of just say, well, let's buckle up. Let's jump into the engine. Let's see some concepts. Let's start to see things in action. And don't worry too much about, the fine details of things, but as we see things working together, they'll start to click and make more sense, right? So, brace yourselves. Now, this is Unity, right? The Unity editor is all about building things, pointing things, clicking things. It's the what you see is what you get sort of thing. It is a GUI, it is an integrated development environment. This is an old version of Unity. This is, 2019 now, right? The main sort of structure of Unity hasn't changed that much, right? So let's go ahead and let's see. I'm gonna flip through these scenes, and instead of looking at them in that context, we're gonna leave it waiting at the GUI system here, and we'll go over to Unity. Now, just for the sake of argument, I'm gonna close this, and I will say save. And you probably know, and for the sake of everyone, this is the Unity Hub. So normally you're not launching the Unity editor, you're launching the Unity Hub, right? The Unity Hub contains all your projects, and it can even have projects that aren't local to your machine. It may be projects that you are part of an organization that uses on the cloud. So if you log into Unity on a new machine, it will check out on the interwebs and say, hey, you actually are part of these projects. Do you want to open one of these projects and potentially know about them, right? Believe it or not. There's some stuff built into Unity to allow you to do that. That's more the Unity collab or team server. Now, we're not going to do it quite from that perspective, right? So hopefully you're going to just, for now, you will see the ones that you have created and have managed on your computer, and the ones that you've specifically put into our Perforce repository. So you probably see a blank list of, there's no list, it's just a blank part here, the projects that you have created. You'll see I have plenty of projects, even more than this, that I am part of. And the two most important, or a couple most important buttons in this screen here, we have the projects, and then we also have installs. You can have lots of different versions of Unity actually simultaneously installed on your computer. So I have all the way back to 2019.3 on this particular laptop, some versions 2020, and we have 2021. Why would anyone want to do that? It's like, well, once you create a program, once you create a game in a certain version of Unity, you probably want to keep that development environment around because maybe you don't want to use the new features of Unity on an old program, but you may need to go back and fix a bug on an old game, right? So you want to keep around the versions that you rely on, right? Or if you're working with a team, maybe you're working with a team that's using Unity 2020 and you're also working on an independent project of your own. You want to try out the latest version of Unity 2021. Perfectly fine. You can do that. You can always add new editors. So for example, here I can see the official releases that I have on my machine. I don't have any pre-releases. Let's see, all. I can then choose to install the latest versions, right? Other versions, 2021 2.8F1. So there's already a newer version of Unity 2021 here, which is not yet an official long-term supported option yet. Long-term support are really, the ones saying, yes, we are committing to supporting this version. So we can expect 2021 to change a lot until at least some long-term support versions. And there's, pre-releases. There's a 2022 beta already. And the archive, well, there may be old versions that we may need to find because maybe we're trying to recreate something that was done in Unity 5 years and years ago. But we want to have at least, generally recent version 2021, probably 2.8F1 is fine or 7F1 fine. All right. I'm not going to install the new version because that would just take time to download here, and I don't want to do that. Then there are the projects. Now, I'm going to go ahead and I'm going to create a afternoon project. So I created an AM temp project, and I'm going to say new project. And from here, let's see, I'm going to go to all templates, and they did this just to make me confused, or I did to myself. Core, let's see, 2D core. I don't want to use the built-in renderer. I wanted to use 2D. Where's our 2D universal render pipeline? 3D sample HDRP. 2D. Oh, there we go. That's the problem. I want to go 2021. All right. First off, 2021. And interesting that the slightly older version, does this one have it? 3D sample URP. There we go. Wow, okay. All right, so you want to have at least 2021.27F1 to make sure we have this sample here, right? Which is the 2D URP, right? So 2D game universal render pipeline. Okay. Now, that's the type of game, and it's really just a template. We can go back and forth, and if we decided later on we want to do something else, we actually could do that. And you're not really totally boxed into a particular thing here. You can even turn a 2D game into a 3D game and so on. It happens. You can do that. And over here are the important parts, that you have a project name and a location. Now for the first one you do location, it's going to probably just have a user's directory that has Unity in it. You put it anywhere you want on your machine, and we could call it something PM project, for example. I'm going to be careful in this case. I want to put it in a particular spot on my computer. So I'm going to click here. And after you start working with Perforce, this will also make more sense. You're going to want to have things that you're going to put in your Perforce workspace in a certain location so that Perforce can find them and the integration with Perforce works correctly. So I've got some things set up. You'll notice there's a users directory, and within users, I can actually, there's already a directory for everybody in there. And I'm not going to put it in any of those. I'm going to put it in this PM folder here. So I'm going to select the PM folder, and hopefully it winds up working with the IT guys to make sure that IT folks to make sure that you will be able to see the AM or PM or appropriate place. So that's where it's creating it on my disk. I've already got that set up, and the project name is called PM Project. Now let's say go ahead, create. Whew. All right, PM Project. All right. I need to have a big clock on my wall. How I've gotten around not having a big clock constantly staring me in the face this long. Everybody still there? Okay. I worry every so often. That's the worst thing about remote lecturing is that, you know, sometimes you're like, oh, did my computer crash? Did my connection go down? I don't know. Everyone's not, you know, I can't see you all on camera. So, the first time you create a Unity project, it will take some time, right? Because it's going to be downloading some components, doing different things, creating all sorts of minty goodness, minty fresh, you know, lemon pledge and all that. Just all kinds of great components and everything all built in. So it will take some time. You see it resolving its packages and so on. Which Unity version did you say we should have? Slightly different. You have 2021 10F1. I would get at least 2021.1.7F1. You might want to update to that to make sure that you can select the 2D URP template for your project like we just said, right? We're going to want to be using the Universal Render Pipeline 2D program. We can get you there from here, even if you have a slightly older version. But if you haven't got very far yet, I would say go in there now before you've created any projects. I'll probably go ahead even, you know, since we see 2021.1.8F1 in there. You know, if you haven't done too much yet, grab the latest. You know, whatever the latest version today is, we'll say, okay, now we're really starting to do work, right? If you haven't run it yet, okay. It changes quick, and usually I haven't run into many problems with it. I've upgraded, downgraded, recompiled projects across older versions, newer versions. Yep. No. No, it definitely will not. It's because its intention is like, okay, once you're using one, it doesn't want to yank the rug out from underneath you, because it assumes that's one thing about development tools, unlike things like, you know, Adobe Premiere or something, where they assume, yeah, we know what's good for you. It's like, no. You know, if you're working on a certain platform, it doesn't want to like rock the boat for you. So normally you need to go out and check to see. You know, it may inform you. You may see like, oh yeah, a new version is available, but it will never automatically update. Right? Unity will not automatically update the editor. Right? Yeah. Okay, so here we are in our new afternoon Universal Render Pipeline PM project. Okay. And you'll see it'll tell us right here, this is 2.7F1. So you can always see like in here, if you're ever curious, you're watching a tutorial and you're not sure, you know, what version of Unity there, you can usually see it right there in the menu or in the window title. All right. One of the big differences you'll see between Unity 2021 and other versions, other than now dark mode is just sort of like right there out of the box. The first thing, if you're used to using other versions of Unity, you'll find this this kind of common toolbar that we're all used to is now just here in the scene window where it, you know, really belongs. And if you're used to the old way of doing it, it's probably, you'll find that it's, you know, you might want it to be up here where it used to be, right? I know I did. It made my life feel a little bit more comfortable. But that's really like one of the only major changes to the interface just yet. That's there, and otherwise, if you wind up looking at the slides in the screen or slides in the presentation or lots of tutorials, you'll see lots of commonality between the two, between whatever versions. Unity's been pretty good about their interface. You may see different ways that things are sort of laid out because we can kind of decide, okay, I want this hierarchy window to be here, right, instead of it being over here, right? It's a configurable interface, but it does kind of come, out of the box with a reasonable layout. You can even save your own layouts the way windows are and so on. I'm not going to choose any of them because I haven't seen all of those. But this is the layout we'll use for today because we'll talk about, again, our objects, our scenes, our components, and so on. We'll put them in here. All right, so by default, here we are. We are in a project. You'll notice at the bottom here we have our project window. Right, this little project tab here. Put that back there. Put the two of them together. Right, you can have tabs within these sort of slots here that we're in. Maybe I should put that there. Now it looks exactly like it used to. All right, so we have the project tab, project window in here. It contains some important things. It contains an assets folder and a packages folder, right? The packages are sort of all of the components that get built in that are part of the system. For the most part, for now, you can largely ignore the packages folder. Don't worry about the packages folder. You shouldn't be touching anything in there, moving things around in there that you don't need to. Instead, we're going to worry about the assets folder. That's where all our stuff is going to live, right? So the main unit of organization is the project, right? Now, the project folder is actually a folder that we have created. And I'm going to say show in Explorer. And if I go to my Explorer, I will find that there is, sure enough, this PM project has a folder on the disk that contains those directories as well as some others, right? There's the assets, there's the packages, but there's also user settings, temp, project settings, logs, library, and so on. So all sorts of automatic stuff that the system will be working with. But it will have, importantly, there's the assets folder and the packages folder. A little bit different contents of the packages folder, but the assets folder you'll see very, very, very similar, right? We have scenes and settings. We sure enough have scenes and settings. We have this universal render pipeline global settings, and there's a file associated with that. But you'll also see some extra files in here that won't show up, these things called meta files, right? Don't ever change a meta file. Really, don't change anything from within the file explorer, right? I wanted to show you this is where it is on your disk, just in case you need to find it, right? Perforce IGP, in my case, Perforce IGP, GSAS, PM project, assets, and so on. So it's there. If I needed to create a zip file, if I in the future ask you, oh, can you make a zip file of your assets folder and your project settings because we want to fix something, this is where you would go. But normally, you do not want to touch any of the files in here. Instead, if you need to reorganize or you need to drag things into the project or import certain assets, do it all from within the Unity editor, because the Unity editor will manage all of those meta files. Those meta files tells the Unity compilers and all the components where to find stuff and what's associated with them. All right, so it's important to know that they're there, they exist. Organize things to your heart's content here in whatever way makes sense. What I often suggest doing is having, let's see, gotta be on the right window here. Since we're going to be doing a couple of things, we might have sort of a general scenes, general settings here, but we might create, for example, a folder called Adventure Game. And you might have another folder called Apple Picker, right? And so on. And then within Adventure Game, that's where we're going to have the scenes that are associated with that and all of the things that are the assets that belong to that. At the higher level, it has the stuff that's already set up. Okay, so the project is the thing that contains everything. All right. The assets folder is the thing that contains all the stuff that we're creating, the assets of the game, as opposed to the game engine and packages and plugins and so on, right? The assets are the things that we're creating that go in the game. All right. So if I looked, I could see, oh, okay, within scenes here, here's my sample scene, which is the thing I'm looking at up here, all right? So the first level of hierarchy is a loose one, and it's this project folder, or the whole project, that contains all our assets. That's that hierarchy. Projects contain assets. And one of those asset types that's really important is, of course, the scene, right? A scene is what is going to contain the game objects that are part of usually maybe a level or the game as far as we're really concerned, right? So here's the game that we're going to be working on up here. If I double click on it, there it is. If I had another scene, let me just use a create scene. There, it's going to create another scene for me. I'll call this one lobby. And if I double click on that, you'll see, well, it doesn't look all that different, except it didn't have a global light in it. So sample scene, let's save that. The sample scene has a main camera and a global light in it. The lobby scene is just empty with a camera in it, right? So now I've got a project that has these two scenes in it, and they're just contained within this scenes folder. All right. Go back to our sample scene here. So within that sample scene, since we're talking about structure and object kind of hierarchy, we have two objects in our scene. This one here is called main camera. Now that's not really a camera object. It's just an object that happens to be called main camera. Sounds a little bit weird, but true. All right, this is another object that happens to be called global light 2D. Okay, it's just another game object. It just has that fancy name. I could call that global light 2D. I could call it Bob if I wanted to. I could call this main camera, well, in case of the main camera, it's a good idea to keep it the main camera, to tell you the truth. But our global lights are, other objects, they can be named whatever you want them to be. Now, object Bob here, game object Bob, just so happens to have some components on it, right? Over here in the inspector window, you'll notice that I click on main camera and I click on Bob and whatever else. Maybe I right click in here. I can create new objects in the scene. So I'll right click and I'll say, create empty. There's an empty game object just called game object. So the empty game object only has one thing on it. It has this sort of automatic component here, the transform, right? This is a component. Every game object will have a transform component. We can't get rid of it. I don't think we can get rid of it. Never tried. Haven't tried in a while. Usually you can't get rid of it. It's the one sort of built-in component that has to be there for every game object. But other game objects, like Bob here, which was our global light, the reason Bob is a global light was because it has a light 2D component on it, right? That's what really makes this game object a light, because it has that sort of component on it. What makes this main camera a camera? Its camera component and its audio listener component and the camera data script that's associated with it, right? So these game objects themselves are just abstract objects, right? This is the has-a piece that we talked about. Each of these objects have certain components that ultimately make them what they are, right? Bob has a light 2D component, so therefore Bob is effectively a light 2D, right? So game objects, and each game object, as we click on them, we can see their components. Now, if we wanted to, we could do, let's see, this would be, isn't this special? I could push this over here so, I could see main camera has those things. Bob has these things. Yeah, that's a terrible thing to do. Leave it the way it was. All right. Now, everyone okay so far, right? So hopefully objects and components are making a little bit more sense. We have game objects and the components on them, right? We're good with that? I'm going to throw you a curve. So I hope you're okay with that. Here's the curve. The idea was, well, all right, remember the cart. We had the cart, and the cart had wheels. Now, a wheel isn't necessarily a component. A wheel is potentially a game object, right? So our cart may be connected to wheels, or actually we'll refer to them as there may be wheels that are children of the cart. There's another level of hierarchy. So within the scene, we have, say here, now I'm gonna rename this. Oops, I'm on the wrong, clicking on the wrong thing here. I'm gonna call this my cart, but I wanna have wheels on the cart. So I'm gonna right click on cart, and I'm gonna say create empty. And you'll notice now that cart, there's a little indent, and you have another game object. I'm gonna call that wheel 1. Wheel front right. Something like that. And then I might say Control D. And I guess it would have been better if I just named them wheel and had wheel, 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 right? So these wheels now are children of my cart. What does that really mean? Well, let's see where that cart is. Right? I double click on that. Usually they say, okay, here's your cart. And we'll use this little move tool to say, all right, we can move this cart around. It's a little bit tricky because, well, a cart doesn't really have anything on it. It's just an empty object right now. But as we move it around, we'll just remember for now, and we'll see this actually happen, that these wheels will move with that cart. They are children of that, right? So you can have children objects, but you have components that are on the game object. So there's a little bit of extra hierarchy here. You have components that belong to an object, and then you have potentially other objects that may be children or parents of other objects, right? There's the curveball. Mind-blowing, right? Yes. Okay. The idea is that, let's see, I'm going to do, maybe doing something a little bit more concrete. Well, let's see, I'm going to need to find an image. I don't know if I can grab, probably can't. No. I'm gonna create a bitmap here, or find a bitmap on my computer somewhere. Another game. Find something good looking. Graphics. 2D game art. Here we go. Look at this a simple way. All right, this will be a little bit weird. I'm going to drag this in here. This is now going to be just an image here. And don't worry too much about it, but here's an image. Okay, you'll notice it's created this object in here. And it's rather large, so I will make it smaller over here. I'll make it 0.1, 0.1, 0.1. 2 would be better. Okay, just so you can see it. All right. So here's a game object, and I don't know what this thing is. It looks like some kind of building. All right. So I'm going to create another game object, just an empty game object, which I'm going to call village. Okay. So a village is going to be made up of, I'm going to call this one building. I'm going to make building a child of village. And I'm going to duplicate it a couple of times. And maybe each one of these I'm going to move around here. It's kind of really going to be sloppy. Okay. So I have 3 buildings that are each game objects, that each of them have some components on them. Basically, the only component is a sprite render that just draws the image. And each of those buildings belongs to, or is a child of, this village game object. So I'm going to select the village game object and move it. And you'll see that all of the children buildings in that village move around with it. Okay, so that's the idea of the hierarchy, that you can have something, a collection of things that kind of belong, they're kind of hooked together. These 3 buildings are children of the village, right? So that's the relationship between the game objects. Then any particular game object is going to have the components that really give that game object its behaviors. Okay? So those are the 2 types of relationships we have, where we have the hierarchy of objects, and then we have the objects that contain components. Okay? Most of the time, you're going to be dealing with objects and the components they contain, as opposed to hierarchies of objects. That gets more into more complicated things, like, you know, if you wanted to have a village containing buildings, right? That sort of structure. So for now, let's go back to worrying about objects and their components, right? So in the interface, we're going to remember that we have over here our organization of our scene, which shows all our objects. And then when we click on a particular object, we know in the inspector it shows the components that that object owns, right? So the hierarchy is all about relationships. The inspector is more about that sort of ownership of components, right? All right. So that's where we were sort of at in terms of this piece here, right? Unity, this is our Unity editor. We can see our scenes within our project, or all of our assets within our project. And the important hierarchy is that the project contains scenes, scenes contain objects, objects have components, components may have other pieces to them like scripts or sprites or wave files, or, you know, so sometimes there is even, you know, the data that's associated with a component, right? And we'll be writing our own components as well, right? We're going to be using Visual Script and Visual Studio to write components that do what we want them to do, all right? So here's the components of this particular object. Like the camera here has a camera component, an audio listener component, and of course the transform component, which tells us where it is in the scene, all right? Now, we're going to roll up our sleeves and think about the first project. So one of the main things that we're going to use in Unity and in any game engine is we normally have, of course, there's the things that are in the game world, right? The carts and the track and so on and so on. But then we also have generally some sort of user interface, some sort of GUI system, graphical user interface system, or heads-up display, HUD, heads-up display for Unity or whatever game system you're in, right? It's a way to get feedback to the user that's sort of, it's invisible to the world, but it's important for us to get certain information across to the player. It's like, you know, I always use the analogy of the heads-up display that, you know, Tony Stark sees as he's looking out of the Iron Man suit. It's like all kinds of information that's obviously not in the real world, but he's seeing that information so that he can know about the world and know the status of this Iron Man suit and, you know, all that kind of stuff. Maybe it has his location. Maybe it has all his game object. Who knows? I don't know what's on those. They look really cool, all those indicators. But we'll have, normally in a game, things like your score, your health, and so on, right? The number of lives left. those aren't things that are in the world. Those are things that's just informational for the user. So they're part of this, generally going to be shown on the heads-up display or the GUI, right? And this is implemented through a special set of objects that are part of the scene, but not really in the world. They're going to occupy sort of a special place, and they're going to be organized on this special game object called a canvas, right? The canvas is this special relationship with the camera also, because it's the thing that we, just like when Tony Stark looks through the eye slits in his suit, he somehow it's overlaying it on the scene, just sort of almost like a augmented reality, right? That's exactly what I guess it is, I suppose. And that can contain things like text and buttons and sliders in our case, panels, toggles, images, all sorts of things that allow us to give feedback directly to the user. So let's take a quick look at that and how that sort of gets set up. Be kind of on the quick side here. All right, so we'll go back to Unity, and I'm going to, for now, I'm just going to disable these things. You can always disable an object in a scene, and then we just won't see it. It'll just kind of go away. All right, so they're gone. I'm just going to double click on the camera to reestablish our context there. Now, once you set up, as you set up your project, there are going to be a few certain things I'm going to want you to do as part of this setup process that will make your life easier later on. First thing being, once you open a project like this, go to the game scene, or the game screen, the game tab, the game window, right? Go to that window, and up here at the top, you'll see it is showing the game. It is showing it on display 1. Leave those as what they are. You'll see you can also scale the game. It doesn't do anything right now because we just have a blank image. But there's an important one here called the aspect ratio, right? Which is going to be how the game gets mapped onto your display, right? Sounds a little bit scary or funky. What I'm going to want you to do, what I'm going to ask you to do is choose 16:9 aspect. This tells the game engine that, yes, you're going to assume that this game is going to be run on a typical monitor or your typical television aspect ratio, which is basically 16 units across by 9 units high, right? The actual resolution might be 1080p, or it might be, 3840 by, I forget the number. The resolution can be anything, really, but the relationship between the number of horizontal pixels and vertical pixels is basically for every 16 pixels across, you have 9 pixels up and down. And that establishes the shape of the display. Okay, we want to do that first off so that as we position objects in the scene, in the camera, and as we position objects on the canvas, we know that they're going to show up in places that someone running on a typical screen will be able to see. Okay, so that's the first thing I like to suggest. If we were developing for an iPhone or something, we would use a different aspect ratio. But for us, we'd use that 16:9. All right. Now, we want to say, well, we want to use a canvas heads-up display sort of thing. So let's put a bit of text, all right, not in the game world, but on the display, on the canvas. So I'm going to do that by right-clicking here in the scene, in the sample scene, and I'm going to go down here. You'll see that there is a section called UI. Now, for now, we're going to use, there's some new text objects, the way, or they're kind of pushing us towards using Text Mesh Pro as our text. But for simplicity's sake today, I want to put the simplest kind of text on the screen, which is our legacy text. All right, so we'll scroll down here, UI, legacy text. All right, so automatically, Unity has created for me a canvas object, which tells the game engine, establishes this relationship between this user interface that I'm now building and the camera and the game world. Okay, that's what it's doing. It's creating establishing that relationship. And on that canvas, it has placed this object called text legacy. That's just its default name. I'm going to call this main message, just for sake of argument here. So main message is now our main message. And if I go to the camera, I'm going to show you two different things here. If I double click on the camera, now I'm going to go back to the scene here. Double click on the camera. There's the camera. I'm going to double click again. Here's the context of the camera. It's a 16 by 9 shape there, but you'll notice I don't see that message, right? It's not there where I saw it a second ago. So I'm going to double click on canvas and you'll see it just zoomed way out. All right, there's our camera was like way down here, but somehow the canvas is this much bigger thing up here, right? This is very conceptual, very loose relationship between the two, right? The canvas doesn't really exist in the game world. So what Unity does is it kind of overlays it, allows us to do the layout and establish what's in that layout, but it sort of keeps it separate from this the game world. So it's a little bit of an abstraction between one and the other. It's a little bit odd, but just think of the canvas. And some other game engines you'll have, just specifically a canvas, entirely different from your scene, and then you have to connect the scene's canvas to the actual, or the scene game world to the canvas and so on. It's a little bit trickier, but in here, this is how Unity has decided to do it. That gives us a canvas which will overlay our scene, and this is how we work with the two. I double click on the camera to see what's in the scene, double click on the canvas to see what's on the canvas. And now with the canvas, back and forth here, I can see that there it placed that text down there, right? Let me flip out that hierarchy. There's our main message again, and you'll see the text all here, right? Now, before I do that, I want to change one other thing. I want to do a little bit more setup. Just like we did the 16 by 9 display, I also want you to go over here and look at the components that are part of the canvas, right? One important thing we want to change is here it says UI scale mode. And for now, let's go click here and say, instead of constant pixel size, because we want this to scale with whatever kind of display. If I run on a high resolution display, you have a lower resolution display or whatever, we want everything to look relatively the same size. So we'll ask it to scale with screen size, right? So we choose that. You'll notice it's moved it a little bit off the canvas already. So we're gonna need to click on it again and move it back onto the canvas, or move it to wherever we want. Maybe we want to move it into the middle of the canvas, right? So we're moving the text there. And let's also, I'm going to make it bigger. I'm going to make it 32 units, and you'll notice it disappeared because it is now wrapping and truncating. I'm going to ask it to overflow the box. It's okay. Or I can change the size of the box. I can alter the box size to make sure it doesn't get clobbered. So now I'm kind of laying out my GUI here, and I'm going to kind of center it, and I'm going to ask it to go ahead and align it to the center, align that to the center. So now I have some text in my display here, right? This main message text. And I'm going to change some data for the component over here. I'm going to get really quick, and what I'm going to do is I'm going to change the color. I'm going to turn it to yellow. All right. So there it is. Now, if I go back to the main camera, I don't see it. But if I press play, you'll see it is now overlaying that canvas with the game, right? So that's what's occurring here. I can switch back to my scene view. I can switch back to my game view, but it's combining those two things. All right. Now, we're going to be adding all sorts of things to that canvas. Largely we're going to be doing things like adding other UI elements like, we'll do a legacy button, right? And let's go back to the canvas, and we'll move this button somewhere. We create a set of buttons, which is going to be our, why can't I move it here? Let's grab that button, there we go. And we're going to create a set of buttons, either for our lobby or for a directional pad and so on. We can kind of have multiple buttons. We're going to change the text on there eventually, and so on and so on, all right? So, important thing to know is that we have these two things, this main camera, which gives us a view of the game world, and we have a canvas, which is our heads-up display. So there's a little bit more hierarchy inside of Unity. Now, just to make things satisfying for the day is we're going to skip over the audio bit for now. And we already talked about the Unity editor and how to be organizing stuff in our project. And I want to write a bit of script. I don't want to leave you without any script today. So we say, okay, how do we write scripts? How do we have them as part of components? So we're going to write our very, very first script in the quickest possible way in 5 minutes. Okay? So here we go. Quick as possible. All right. So in this sample scene here, I'm going to create yet another empty game object. Create it empty. So I'm going to have lots of potential game objects in here, but I'm going to call this one something special. I'm going to call this one Game Manager. Right? This is going to be my Game Manager object. And in your first program, I'm going to ask you to have a Game Manager object. Right? So we have that Game Manager object you'll see here. It's called Game Manager, has no components on it. I'm going to add a component, and I want to add a custom component called, it's going to be a script. So I want a new script. And we'll call this one also, for now, I want you to create a Game Manager. Whoops, what happened? Game Manager. You say script and say create and add. All right. So it is now created a component on here that is going to be a script component that will execute some script, thereby making my component. So I'm going to double click on that, which will open Visual Studio. So you can double check to make sure that Visual Studio is installed this way. And the code I'm going to run, of course this shows up on my other display. We'll give it a second. Come on. You'll see Visual Studio looking a lot like this on your computer now. And this is going to be, it's created a class for us that is named Game Manager. Don't change this name. So it has created this component and established these interfaces, these events that will happen, that we will write code to respond to. So the code we're going to write, simple. We're going to say print, that's going to be the name. We're going to call a function called print, which is in the system, already exists for us. You'll see it saying, okay, here's the print message. And we'll say, hello, Unity. Right? It is a string, which is why it's in, quotes. And we're going to end that statement with a semicolon. So we're going to write, we want it to print somewhere as a response to this start event. We'll look at the syntax of this next time. So we're going to save this, Control S. We'll save this script, and now if I go return to Unity editor, it will say, okay, I'm reloading, I'm compiling, I'm making sure everything's okay, and nothing has happened. Right? Now there's this console. That's the other piece of the UI I want to introduce. The console, whenever you print something, that's where it shows up. So we're going to press play in our game, and you'll see over here in the console, if all went well, you'll see hello Unity, right? Because now we have a function that is being called in response to an event, and that function is responsible for talking to the system and printing out a little bit of text. Now, the button is active over here. You'll see this button is active, but it's not doing anything yet because we haven't associated any code with the event of a button being pressed. We'll talk about that next week. All right, so that was the main thing I wanted to make sure to get to say, okay, we've got a little bit of code. You can put any game object, you can put any number of game objects in there, and we'll talk more about the components and, what's going on in these scripts. What does this start? What does this update? And so on. But we're, at least conceptually, we've kind of jumped up and down the whole traffic flow there. So we wrote our first bit of script. There it is. It's a part of the presentation. It's a simple print statement, right? A function to print text to the console. Hello world. The rest of this presentation, for the most part, recaps that same stuff on the project that you want to start developing, right? So the non-hand-in part of the homework is to go ahead and try, watch back. If you want to refer back to the video, this will be up on YouTube. I'll post a link for it. And at least go through the process, put in a game object in a scene and have the start routine or the start event for that game object trigger a simple print to the console. All right, that's the do it at your own pace piece. But also the important part that you are going to want to hand in, and don't worry, I think we'll have a class. We do have class on Tuesday, right? We'll talk a little bit more about this before it's due at the end of the day at midnight. You're going to want to put together a design, right? And think of the design as being, read all of the criteria here, get the idea for, what the basic mechanics and mechanisms of the game should be, and then start to fill in the blanks of, your narrative, your story, the player wakes up in the dark room and what happens next, right? How does the user navigate this sort of simple, immersive world? Think very, very simple. Don't get carried away. How do you create an object? What does that object need to know about? What does the player need to know about? They need to know their position in the world. They need to know how big they are so they can interact with things, right? If they bump into things when they are within a certain distance of things, for example. You might need to have certain sounds when they bump into the wall or they step on a cat or they do whatever they're going to do. It's up to you, right? So 1 page, quick set of instructions to yourself about how you want to design the game and what's the narrative. Think of it in mind with, like, if you needed to hand that to someone else in this class, they could create the game based on that. Is it enough information? That's sort of the level that we're looking at. Not painstaking detail, but general, given a commonality of requirements and outcome, and your customizations, what assets you need, and so on. Right? That's the idea. I'll post an assignment on LMS that you'll be submitting that to, and stay tuned on Discord. I know this is a big one. There's lots of stuff, conceptual things. It'll start to slow down, and we're going to be looking at sort of more individual components and how each one of those work. But as you're approaching Unity for the first time, now you should have a decent idea of where things are in the interface and sort of this notion of the different hierarchies and the different relationships between components and objects and so on. Okay? All right. That's it. That's all the time I've got, so I'm going to have to let you go there. I hope none of you have class after this. I hope you're done for the week and you can enjoy your weekend. But be thinking about, how you want your little text adventure game to work. If you have any questions, go ahead and post them on Discord. Justin, you know about Real Sound on the Dreamcast. Okay. All right. Yes, I worked on that. But anyway, it's Warp and everybody who's associated with really, really great people. It's a shame that Kenji passed away a few years ago. But anyway, okay. If you have any questions, some good stuff. Okay. Can you use Visual Studio 2022? Do you specifically need to use... I cannot make any claims with regards to how well the integration with Visual Studio 2022 works. I recommend using the version that Unity is going to install, because there's going to be some certain assumptions about that, especially when it comes to debugging. So install, if you have got the space for it, hopefully install a version that Unity brings along for the ride. Okay, so that the debugging works, especially debugging and code completion work correctly. You don't want to be working without that. So other question, wait, how come the text shows even if the camera is way off, right? Because the camera, during the scene building part, the camera is what's showing us in the game world. It doesn't get connected together until we actually play the game. Then the system overlays the canvas on top of the camera, and then everything works out. Okay. So it's that moment we hit play, that's when it works. All right, so I didn't have to make a canvas specifically because the canvas made itself the moment I tried to place a UI element. Right? Unity will sometimes do things automatically for you. You know, it knows that, oh, you try to place a UI element, you must need a canvas to put it on. So it did that for me. All right, so that's it. Everybody, thank you so much. Thanks for letting me run over by 2 minutes, 3 minutes. I'll make it up to you at some point. If you have any questions, post in Discord. Email me, let me know what's going on, and we'll get there from there. Justin Justin RTA should also be monitoring the Discord more often now, as well as Rebecca. She'll be around looking through things. Don't worry if you're lost now. We'll revisit things a lot, and you may want to come back to these lecture notes after you've just tried some things out, put some things in the scene. Okay, don't worry. It's a lot at first, but you sort of have to just kind of get a whole bunch of stuff at first, just to kind of at least see it. But get Unity on your screen, and then we'll get there. Okay, think about the design. Don't worry about the specifics. Think about that design. All right, it'll be okay. All right, have a great weekend, everybody. You too. Sure. The design. Yes. It is effectively, it's going to be the design, right? There's nothing about like not a paper about the design. It is the design and sort of whatever you need to do to implement that, right? So it's a design document. So it should say, well, the game has these things and it needs these components, and right. So if you handed it to someone, yeah. No implementation. No implementation is strictly conceptual. It's a concept design at this point, right? Not an implementation yet. Don't worry, that comes later. Believe me, I don't expect you all to have that point. I just want the description of your game, how you're going to get there, what it's going to do, and so on, right? So that you're going to have a plan to work from as you implement, right? This is design, not the final version. All right? Okay, you too. Take care.